All right, how we doing, everyone? This is Mr. Rushka here. Welcome back. All right, today we're going to do the Chapter 1, Section 2 notes, the 3.2 notes that are due for B period for tomorrow. And then for E and F, they're due on Wednesday, September 13th, okay? So let's go ahead and get started. So we're going to go ahead and start with a few definitions here. So we're going to start out with a relation. We're going to talk about what a relation is, okay? A relation is a set of ordered pairs. It's a set of ordered pairs. Okay. All right, so let's say 0, 3, 1, 1, right? And -2, 5, right? This is a relation. It's three x values. So there's an x here, a 0, a x value here, a 1, and -2, right? And they're paired up with a y value, corresponding y value, okay? They're paired up with a corresponding y value. So this is a relation right here. This is a relation. Oh, let me switch to my pen. Relation, okay? We can have as many ordered pairs as we want in our set. In this case, we have 3, okay? The domain of a relation. The domain of a relation is all the x components in our relation. Right, so that would be, here it would be 0, 1, and -2. So 0, 1, and -2. This will be our domain, okay? It's all the x values that are part of a relation, okay? The range is all the y components. All the y components in our relation. Okay, so that's the range. So the range here, let me get a different color. The range here would be 3, 1, and 5. So 1, 3, and 5. This would be our range. Range is right here. There's our range, okay? All the y components that are part of our relation, okay? So that's how that works. All right, the second thing we're going to define, or the next thing I should say that we're going to define, is a function. It's a function, okay? So a function is a special type. It's a special type of relation. Okay? What makes it special? What makes it special? Okay? What makes it special is that each x value has only a single y value that it's paired with. Each x value is paired with a single y value, okay? So an example of relation that's not a function, okay, I'm going to erase all this here. Let me give you, so this is going to be not a function. Yeah, the keys. Yeah, thank you. I haven't graded it yet, no. So.
And then I have my Unit 2 online, just download a copy too.
Thank you, yeah. I got it off Schoology already. I already have it over here.
Okay, good.
Thank you. All right, so an example of relation which is not a function. All right, I'm going to give the ordered pairs 1, 2. All right, 2, 3. And 1 comma 4, okay? This function is not a relation. This is not a relation right here, okay?
That is a relation.
All right, Mr. Shadio just pointed out it's not a function. Thank you. This relation is not a function. Not a function, okay? Why is it not a function? Because my 1 here is repeated. I have my x value is repeated. My 1 is linked to 2, and my 1 is also linked to 4. Because my x value repeats, this is not a function. This is not a function. It is a relation. It's not a function. This is not a function, okay? Let me give you an example, one that is a function, okay? Is a function. Let's give you an example of that, of one that is a function, okay? So if I give you 2 comma 4, right, negative 5, 6, 7, 3, negative 3. All right. So notice here, each of our x values, these appear only one time. There's no repeating x values, okay? So that's a function. This is a function. It's a relation which is a function. So every function is a relation, guys. A function is a special type. It's a special type of relation, okay? But not every relation is a function. Not every relation is a function, okay? All right, so now the vertical line test. Vertical line test. All right, so let's talk about the vertical line test. The vertical line test is something we can use to figure out whether a relation is a function. And we can do that by graphing our relation, okay? Okay. So the vertical line test, okay? Let's go down here. Okay, so we have a graph right here, a graph of a relation. This is a relation. So all of the x values, based on this graph here, all of the x values of our graph, they have a corresponding y value. So if I go to the point x equals 2 and I go up to the curve, I found that x equals 2 has a corresponding y value of 4. So I had the point 2 comma 4 is on my graph. It's part of my relation, okay? Now I know that this graph here, that this graph I'm looking at, is a function. How do I know that? You can do something called a vertical line test. You can do something called a vertical line test. Okay? So if I draw a bunch of vertical lines through my graph, anywhere I draw a vertical line, a perfectly vertical line, notice that the curve can pass through that line, through each line only one time. It only intersects each line one time. Okay? So here it only intersects one time. Right, intersects one time here, one time here, one time here, one time here, right? It only passes each vertical line one time. That means that each x value on my x-axis has only one y that it's paired with. It only shows up one time in my relation. It only has only one y value that it's paired with, okay? Up here, my relation that wasn't a function, right? My 1 got paired up with 2 different y values, okay? Down here, anything that I can draw a bunch of vertical lines through, and the graph passes each vertical line only once, that's a function. That is a function, okay? So that is a function. Okay. Let's use the vertical line test for this next one, okay? Let's draw a bunch of vertical lines through it. Uh-oh, what's going on? Right, I can draw a bunch of vertical lines. where the graph passes through the vertical lines twice, right? So this graph, right, it intersects all these vertical lines twice. Okay, so we conclude that this is not a function. Not a function, okay? Does not pass the vertical line test because it passes through a bunch of these vertical lines twice at two different places, okay? So this is not a function. Not a function, okay? Three more. Okay. Let's draw a bunch of vertical lines. All right. What are we seeing? It passes through each vertical line one time and only one time. Only one time. Okay, so this is a function. My graph passes through my vertical lines, all my vertical lines, exactly one time. So it is a function. Over here, right, what do you think we're going to find? Draw a bunch of vertical lines. Oh, that is not a good line. Draw a bunch of vertical lines, right? Each vertical line gets passed through only one time by my graph. My graph passes through each vertical line one and only one time. It doesn't curve back around and pass through them again. Okay, so this is a function. This is a function. Then part E, right? Look what I can do. I can take a line right here and I can draw through my curve right here. I can draw through my graph right here. Okay, look what happens. So this vertical line right here that I just drew, the graph passes through that vertical line twice. Twice. Same thing here. It passes through this vertical line twice. So we conclude that this is not a function. Not a function. Not a function. Okay? So the ones that are not functions, right, they pass through some of my vertical lines in two different spots. The graph passes through some of my vertical lines twice, right? The ones that are functions, for any vertical line I can draw through the graph, each line gets passed through only once. Okay, intersects only once, okay? All right. Let's go back to domain and range, right? What's my domain again? Domain is all the x components in a relation, okay? So I have a relation here, right? It has three ordered pairs, right? What's my domain? Well, I have 1, I have -2, and I have 1 again. So my domain is 1, -2 with my squiggly brackets to denote the set. Okay, that's my domain. This is my domain. Okay. Let's change colors, underline all my y's, okay? All my y's are going to be my range. So -5, 4, and 6. Those are going to be my range. Okay. Right, remember up here, range is all the y components in our relation, okay? Is this relation a function? Think about whether this relation is a function. Maybe pause the video here. All right. What repeats? I have my x value here repeat twice, okay? So it's not a function. This is not a function. Okay. Over here, part B, let's determine my domain. Let's determine my domain. So I have -2, 0, and -6 are all my x values. So -6, -2, and 0 is my domain. That's my domain. My range, let me switch colors. Underline all my y values. So I have -6, repeats twice. This is -7. So this is my range. Is this a function? Is this a function? All right, well, -2, 0, and -6. So none of my x values repeat. None of my x values repeat, so this is a function. Is a function, okay? Notice that I have my y repeats right here. -6 shows up twice, right? But this is still a function. It is still a function. That's because in a function, none of my x's can repeat, but my y's can. My y's can and sometimes do repeat, okay? And then part C here, right? So my ordered pairs, let's talk about my domain and what the ordered pairs for this one would be. My ordered pairs would be A, comma 1, A, comma 2, right? So A gets output to 1, it gets paired with 2 as well. All right, B gets paired with 3, and C gets paired with 3, okay? All right, so what are all my X values? I have A, B, and C. So the domain of my function would be A, B, C. That's my domain. The range of my function is 1, 2, 3, and 3 again, okay? So we don't have to write the 3 twice. So let's just do 1, 2, 3. That's going to be my range. Okay. Is this a function? Is this a function? Well, look. One of my X values, that first value in my ordered pair, repeats twice. A shows up twice. So this is not a function. Not a function. Not a function, right? Okay, let's come over here. So here's what we got so far. Hopefully, if you're not understanding, hopefully you can rewind it and that helps. Okay. Over here, let's determine whether each relation is also a function, okay? So we have y equals x plus 3. Y equals x plus 3, okay? Right, so if this is not a function, there's 2 ways we can do this. We can do vertical line test. So we can do vertical vert line test. So if we graph it, we graph this function. Well, okay, I just spoiled it. If we graph this relation, we get something that looks a lot like this. Right, you can try plugging it in your calculator. You're going to get a line that looks like this, okay? Notice, okay, I'm going to switch to pink. If I try to draw, anywhere I draw a vertical line, my graph passes through the vertical line once and only once. One time and only one time for each vertical line. So I conclude that yes, this is a function. So yes, circle it for Mr. Rushka. This is a function. All right. I'm just filming a video for my class and I can help you. All right, so for this next one, we want to see whether it's a function, Okay. So this is x equals 3y squared. Okay. First thing we're going to do here is we're going to solve for y. Solve for y. So I'm going to divide by 3 on both sides. X over 3 equals y squared. I have to take the square roots. Remember, when I solve for y, by taking the square root, I got to put plus or minus in front of my x over 3. Okay, so I get y equals plus or minus square root of x over 3. Okay. Now, when we graph this, we have to graph 2 curves actually in our TI-84 graphing calculator, or 83 if you have that. You get y sub 1 equals positive the square root of x over 3. You're going to graph y sub 2 equals negative square root of x over 3. So try that. Maybe pause here, try that in your graphing calculator. You should get something that looks a lot like this. It should look a lot like this. Okay? It's going to look like a sideways parabola. And then notice when we do the vertical line test, if we try to draw a bunch of vertical lines through my graph, a lot of them intersect my graph. Let's use a better color. Let's do blue. A lot of them intersect my graph in 2 different places. They intersect in two different places. So this is not a function. No, not a function. Not a function, okay? So these first relation is a function, second relation is not a function, okay? So let's go down. We already did all the vertical line stuff down here. Let's talk about 4. We're on heading 4 right here, heading 4. Find all the indicated values of f of x equals 3x minus 2. So this is what's called function notation. Basically all I did was instead of writing y equals 3x minus 2, I wanted to specify, if I want to graph two different functions or two different relations at once on the same graph, I don't want them to both be called y. Okay, so I basically just renamed them f of x and g of x. Okay, I renamed them f of x and g of x. Okay, so down here, over here on part A, f of 1 is what I get when I plug in 1 for x over here, okay? So f of 1 is, now let me plug in 1 for x over here. So I get 3 times 1 minus 2, which equals 3 minus 2, which equals 1. Okay. So there's that. All right, and then over here, I have g of x equals 5x squared plus 2x minus 1. Okay, so g of negative 2, that's what I get if I plug in negative 2 for x here. So I get g of negative 2 equals 5 times negative 2 squared plus 2 times negative 2 minus 1. And then to calculate this, right, use my order of operations. So I do exponents first here. I get 5 times 4, and then I can do my multiplication here, plus negative 4, and I still have my minus 1. So then I have 20 minus 4 minus 1, or 15. So g of negative 2 equals 15. So I just plugged in negative 2 into my g of x here. Okay, f of a. Same deal. I'm plugging in a letter, but I still just plug it in. F of a, wherever there's an x, I put an a. So I get 3a minus 2. And that's it. All I did was I took the letter a and I replaced x with a. Okay, I got that over here. G of negative x. So anywhere, here I would do that, right? Over here, anywhere there's an x, I replace it with a negative x. So g of negative x equals 5 times, and I put in this in parentheses, negative x squared. I got to put it in parentheses. Everywhere there's a positive x, I put a negative x in parentheses. Plus 2 times negative x minus 1. So I get, again, 5 times negative x squared is just x squared. All right, 2 times negative x is minus 2x, and then I have that minus 1. That's g of negative x. Okay. F of x plus h, I keep doing the same thing. So up here, I'm going to look at f. You can see my board, I look at f. And everywhere there's an x, I replace it with an x plus h in parentheses. So let me switch colors here. F of x plus h equals 3 times, in parentheses, x plus h minus 2. Okay, so where there was supposed to be an x, I just put an x plus h in parentheses. So that's my answer here. That's my answer. Okay. Now I have g of 3b. And again, anywhere in g of x, anywhere there's an x, I just replace it with a 3b. So g of 3b equals 5. And then in parentheses, 3b, all of that squared. I have to put my parentheses around my 3b, okay? And then put the exponent outside of it. So plus 2 times 3b minus 1. So let's square 3b. That gives me 9b squared. Okay, 2 times 3b is 6b, and then my minus 1. So that gives me 45b squared plus 6b minus 1. That's g of 3b. Okay, that's my answer. So anywhere, right, I take whatever's inside my parentheses, and wherever there's an x, I just replace it with whatever's inside my parentheses. Okay, and I make sure on the other side I put everything in parentheses as well. So I put my 3b in parentheses, squared it, put my 3b in parentheses, multiplied it by 2. Okay. So there's that. Now over here, we want to find f of 1 graphically on a graph. So we want to find f of 1, okay? Here's my function f, my curve f, okay? F of 1 means find f when x equals 1. So we want to find y. We want to find y when x equals 1. Okay, so let's do that graphically. So let's start at x equals 1 here, and then go down to my graph, hit the graph, and I go over to my y-axis, and I hit -3. So f of 1 equals -3 here, right? I went down, I started at x equals 1, went down to my curve, to my graph. Once I hit the graph, I went over to my y-axis, and I got -3, okay? That's what I got over here. F of 0, okay, same deal. I start at x equals 0. I go down to my graph, hit my graph, and then I'm already on the y-axis. So I just stay there, so that equals -2. So my y value I have right here is -2, okay? See, g of -2, g of -2. So I start at -2. I go up to my graph. I hit my graph, and I go over to my y-axis, and I hit 3. I hit 3 right here. So g of -2 equals 3. Okay. G of 0, I start at x equals 0, and then I go up to my graph. I hit my graph, and I'm already on the y-axis, and I hit 1 here. So g of 0 equals 1. Okay. So that's how we do it graphically. That's how we do it graphically, okay? Now, part E is asking us to find all x values such that f of x equals 1. So I'm looking at this problem here. I'm looking at this problem here, okay? So we're still using these same graphs, okay? Let me erase everything up here. Okay? I want to find all the x values such that f of x equals 1, or such that y equals f of x equals 1, okay? So what I do here is I go on my y-axis here, my y, or my f of x axis. These are my f of x values. All right, look at 1 here, right? I'm going to draw a dashed horizontal line through y equals 1. So I drew the line y equals 1, and then I'm going to look at the x values. Oh, that's not a good color. I'm going to look at the x values. I'm going to look where that line, that dashed line, intersects my graph, and I'm going to look at what x values are right underneath those points. So I have -1, and I have 3 right here, okay? So x equals -1, x equals 3. Those are my solutions, okay? All right. Part F. Let's find all x values such that g of x equals -2. So now we're looking at the g curve over here, g of x. All right, and we're going to go ahead and draw a dashed line through -2 here. Y equals -2. All right, draw a point wherever it intersects my graph here, and then see what x value that's right underneath. That's right underneath x equals -3. So x equals -3. Right. So if you don't understand that, just pause, go back, rewind. If you have any questions, just ask me in class tomorrow, okay? All right, and then we'll do a homework assignment on this together. We can get this ironed out, okay? All right, you guys take care, guys.